Alright, so let's have a look at this one. The particle is thrown from point O at the top of a very tall building, not just tall. The equation of motion is given to us, S double dot, it's a vector. And you can see it's got two vectors in it. It's got the S dot vector and the J vector there. S of t is equal to x of ti plus y of tj. So that's like the displacement. So the first one is the acceleration equation. So it's all as normal. And if we interpret the question as it asks, so here we've got what is the physical interpretation of the constants u and alpha in the expression for the initial condition? So the initial condition, expression for the initial condition is down here. And clearly, so S dot, we're dealing with the velocity of this particle, and it's broken into its horizontal and its vertical components. So we know u is just the magnitude of that initial velocity. So we could say u represents the speed, the initial speed, I should say, of the particle, and alpha is its trajectory from the angle between the horizontal and this, where this particle is projected. How do I say that nicely? So alpha is the angle between the direction it's thrown and the horizontal. All right, so let's kind of move that up. Move that one up. So part 2, we're going to consider the horizontal equation of motion and find an expression for x of t. So we're looking at the horizontal, consider the horizontal equation of motion. Oh, why does it do that? I'll just move it across there. Okay, so consider the horizontal equation of motion. So this is, you can see that, I can see that we've got some gravity happening in that bit, but we've also got some resistance, and it's proportional to velocity, so it's a linear drag that we're dealing with here, okay? So it's linear drag. So if I have a look at my, we've done this in a different example, so my x double dot equation, it would usually be 0 if we didn't have any drag, but in this case we have drag and it's linear drag. So that's our equation for our horizontal acceleration. So remember, x double dot is just the derivative of x dot, so it's the same as d to t of x dot. Okay, so we can actually use our separable equations here. So if we keep this minus r and dt it, as it were, and we put this x dot on the other side, so we've got 1 on x dot and dx dot it. Okay, so this pen, not great. And I'm going for t, of course, between 0 and sometime t for x dot. So this is with respect to x dot that we're doing 1 on x dot. We'll go from x dot, the beginning, so here's the initial x dot, u cos alpha, up to some value of x dot. So here we've got log of x dot, log of our x dot between our u cos alpha and our x dot, and here we've got minus rt. So having a look at that, we'll get, of course, log. Now what are we after? We're after, of course, the xt equation. So we're after the x equation. So we've got to do the x, find x dot, and then go to integrate again to find x. So instead of putting this together, I'll keep it separate. So here I'm going to have log of u cos alpha. So I'm going to have log x dot equaling log of u cos alpha minus rt. So that keeps my x, this is an x dot, which is hard to see, keeps my x dot separately, which is what I want. So now if I exponentialize both sides, I've got x dot by itself. And here, if you think about it, I could do e to these, so e to the something, let's say a minus b is the same as e to the a dot e to the negative b. So I can kind of separate out these terms. So the first term will become u cos alpha when I exponentialize it, and then I'm multiplying by e to the minus RT. So that is my x dot, but remember the question did say to find my x. So now I want to integrate with respect to t to get my x. So I'll just do it straight. This is a constant, that part, and this I'm integrating with respect to t from 0 to t in order to get my x equation. So I'll still have, I want a minus r, so I'm going to divide by a minus r. I want a minus r, so divide by a minus r there. And then my integral works really nicely. So I've got so I'm going to get u cos, here I am going to get, when I put t in, oops, where's my minus here? So when I put, so I have e to the minus RT, take 0 and t, and when I put, running out of room, minus u on r cos alpha, I feel like I've done something wrong, e to the minus RT, when I put 0 in I get minus 1. So actually I could put the minus through and make it look nicer by just swapping this around. That's what I meant to do before. Alright, so I've got 1 minus e to the minus RT there. And that gives me the equation for my x of t. Okay, I might do the others in a separate video.